All right, so part two really is the same concepts, but some application questions. And then as well, doing the opposite of, we talked about opposite or inverse operations, of showing a mixed radical, showing it as an entire radical. So basically getting all of the numbers back in the radicand. So first thing is an application, and it's a right triangle, and it says determine the hypotenuse. Hands up. What's the formula to use for that? Yep. Right. And which is the hypotenuse, A, B, or C? Okay, so here I'm going to put it C squared equals just so that it's on the left, but it doesn't matter. And so this I'll call A, this I'll call B. Again, that doesn't matter which one's which. We call those the legs of the right triangle. And so that's going to be 36 plus 100, which is 136. And then remember, to solve that, we take the root. Now, if this wasn't an application, it would be either positive or negative. But for a triangle, you can have a negative length. So it's going to be the positive root of 136. And it says simplified exact value. So an exact value is not a decimal that repeats or, that doesn't repeat or terminate. So putting 136, taking the square root in your calculator does not give you the exact value. That is exact, but it's not simplified. So remember yesterday, we went and decided, okay, 136, either you used prime factorization or you figured out a perfect square that's a factor of 136. So I noticed that that's even. I'm going to just show some work and see 4 goes into it. So that goes in 3 times, 34 times. Then I think, okay, 34, what are the factors of that? 2 and 17. No perfect square in that part. So that's what I can show. And remember, my analogy, the perfect child gets to go out on the weekend, and the 34 has to stay home. And in this case, we need the units. Okay. So let me just check. My calculator, my TI, is not going to simplify it. But if I put in the square root of 136, and then I put in 2 square root of 34, you can see I get exactly the same value, decimals. I'm not going to write that down, but I know that I haven't messed up. Okay, I've simplified it, still the same number. Doesn't necessarily mean you simplified it fully, but in this case we did, because 34 you can't do anything more with. Okay, so that's a really common application, is the Pythagorean theorem. Here's another one. A box has a length of root 5, a width of root 6, and a height of root 3. Determine the volume of the box and write the final answer in simplified form as an exact value. So remember, volume of a box is a prism, is length times width times height. So root 5 times root 6 times root 3. So when you're multiplying, we're not going to do a whole lot of multiplying, but basic ones like this, you multiply all of those radicands together. So that's going to be 30 times 3 is 90. Kind of went a little big on that. When you are doing a square root, I'm going to fix that up. Be careful about how you show it. I see kids go, oh yeah, something like that, because they're messy. Well, that almost looks like root 9 times 0, right? Because the radical sign isn't over top of all of 90. So make sure you are very deliberate by putting the whole number underneath the entire radical sign. Sometimes I will put a little sort of tag at the end to close it out, right? So I know that everything is in there. Now, I have to simplify this. We did root 90 yesterday. Hands up, what's a perfect square that's a factor of 90? 9. So this is the same as 9 times 10. 9's the perfect square. So it gets to go out on the weekend. 10 stays home. Okay. In this case, the volume would be centimeters cubed. Okay. Now, this one you might not remember. Surface area of a sphere. Anyone know it? We're going to review it this semester. But anyone know what the formula is? Already? Is it, remind me your name, Ian? No, William? Yep. 4 pi r squared. Yep. So we would give it to you on this test. Once we do the measurement unit, then we'll give you a formula sheet that has the formulas. But here, surface area of a sphere is 4 pi r squared. So now we're told that the surface area is 32 pi. And it says determine the value of the radius. So think about solving this equation. We need to get r squared by itself. So we're going to divide both sides by 4 pi. We're not going to use the decimal form of pi. There's no need to. Okay? We're going to divide that out. So those divide out. The pi's divide out, because that's a factor, common factor. And then 32 divided by 4 is 8. So 8 equals r squared. So it's like the Pythagorean theorem one. We take the root of both sides, and the radius can't be negative, so it'll be root 8, which you can simplify. Root 8 is going to be a pretty common radical, so you'll probably end up memorizing that simplifies to 2 root 2, because 8 is 4 times 2. That's a perfect square, so 2 root 2. And this would be centimeters. Okay. So those are a few application questions. Then question 1, express the, so this one is no application, but it's expressing as entire radicals. So we're taking that number that's on the outside and putting it back in, the opposite of what we were just doing. So this is in simplified form. What would that have been originally? Well, think about what we did back up here, right? The perfect child went out on the weekend. Well, they have to come back home. When they come back home, they're worth 4, right? 2 here, 2 squared is 4. Up on this one, root of 9 was 3. When they go back home, they're worth 9. So we have to square the 3 and multiply it by whatever was still in the radical. So here, we have to square the 2 and multiply by what was already in there. So that's 4 times 5, which is 20. So root of 20 is the same as 2 root 5. Again, you can check by putting both in your calculator and getting the decimal form. Okay. Here's the deal on B. It's got a negative. So if we square a negative, think about that. If we were to square negative 4, we get positive 16. So don't write this down, but if I did that, I would have, so negative 4, don't write this down, I just want to show you. I would get that, which is 16 times 14, which is a positive number, right? What is 16 times 14? 2 what? 224? Well, 224, if I take the root of 224, I get a positive. This says it's a negative. So if you have an even root, so a square root or a fourth root, sixth root, etc., then you have to leave the negative outside. So we're not going to show it like this. That's why I said don't write that down. We're going to leave the negative and then go 4 squared times 14. So it'll be negative 16 times 14 and 224, right? So when there's a negative and it's a square root, you can't get it all inside the radical. So the negative stays outside. Okay. Okay, now we'll look at cube roots, I should say. So that means we have to cube the value that is on the outside, right? Because 3 is what it was worth after it was simplified on the outside. So to put it back in, you have to cube it. Okay, 3 cubed is 27. 27 times 4 is what, 108? And remember that cubed root. So here, if I were checking this on a test, had something like that, I'd go, okay, the original was 3. Oops, let me just move this over a bit. 3. And then my cubed root is go math. And if you go down to number 4 there, this is in the TI. I'll show you the Casio after we're done all of this. So that's the value of the original. It actually puts brackets in this version of the TI. Then if I do my, if I say I forgot the cube symbol and I just go, oh, I'm just going to do square root of 108. So you actually get the radicand correct, but notice how it's a different value because I didn't have the cubed root. So I've got to go math cube root of 108, and then I get the same value. Okay? Can't just drop the 3. Now, for a negative with a cubed root, that you can have a negative in the radicand. So this one, we can do negative 10 cubed times 4. Right? And so that's negative 4,000. Okay? If you left the negative outside, we'd still probably allow that. But with an odd root, like 3, 5, 7, etc., you can have a negative. So might as well get everything underneath there. It's called an entire radical for a reason. Okay? This one here already has the negative inside, which is fine because it's a cubed root. When the 7 goes back home, it's worth 7 cubed. And I always forget what 7 cubed is. It's on your chart. 343. And then times 3, we get 1,029. And F is a fourth root. So to put that 2 back inside, we have to raise it to the exponent 4. So it's almost like you're taking that little 4 and making it the exponent on the coefficient. So what's that? 70, 42 is 212. Oh, sorry, 112, right, 112. Okay. Now, in terms of comparing numbers, guys, in terms of comparing numbers, so this says express in ascending order without the use of a calculator. So you're gonna have to show work. Okay, because yeah, you can punch it into your calculator, but this says without, and even on a test, that's not really testing anything if you just punch it into your calculator. We're going to want to see how can you figure out what order these values are in. So ascending order, who can tell me, is that lowest to highest or highest to lowest? Hands up. What do you think ascending? Hudson? Lowest to highest. If you ascend a mountain, you're going up the mountain. If you descend a mountain or descend a set of stairs, you're going down. Okay, so we want the smallest to largest. Let's first show them all as entire radicals. They're all square roots, but it's hard because, well, actually, no, in this one, do we even need to show them as entire radicals? No, because all of the coefficients are the same. So it's all 4 times something. So obviously, root 5 is smaller than root 6, which is smaller than root 7. So we started a little too easy on this one. Okay. Now, if the coefficients are different, like in this one, and the radicands are different, then you do have to show them all as entire radicals. So now for this one, I'm going to do, okay, so 9 root 2 is going to be 9 squared times 2, which is 81 times 2, is 162. Okay. 5 squared times 6. So 25 times 6, 150. And 8 squared times 3. So 64 times 3, 180, 192. Okay, so now we can tell root 150 is the smallest, and that was 5 root 6. Then root 162 is the next biggest, that's 9 root 2, and then 8 root 3. This 3 dots here in a triangle means therefore. It's a fast way of saying therefore in math. And then last one, these are all cubed roots, right? And they all have different coefficients and different radicands. So you have to show them as exact or entire radicals, I should say. That plane's close. So 3 cubed times 5. So that's 27 times 5. So 20 times 5 is 100. 7 times 5 is 35. So oops. and do 2 cubed root 15. So 8 times 15, 8 times 10 is 80, 8 times 5 is 20. No, did I just say 8 times 15? 8 times 5 is 40, so 120. And that's going to be 4 cubed times 2. Uh, 64 times 2 is 128. They're all pretty close, right? So the smallest is cubed root of 120. So that is 2 cubed root 15. Then 1 cubed of 128. So that's 4 cubed root of 2. And then of 135, that's 3 cubed root of 5. All right, so if you take a look at the timeline, we've now finished the mixed and entire radicals part 2 that is listed for tomorrow. Okay, so you can do the practice that's in the sheet there. So that's right following what we just did. So there's these questions here, do those first. Make sure you've done the practice, everything in the practice section up until now. And then you can access the textbook through D2L and do the textbook questions. Page 206, 28 was from estimating, 218. Yep. Oh, yeah, there's no Wi-Fi. I think I have, I can get it up on my board and save it. So, yeah, there's no Wi-Fi, so you would have to use data if you have got the app on your phone. But I'll get at page 218 so that you can work on that. Okay, and then tomorrow, as I said, is going to be practice day, putting it all together. So let me see if I can, okay, let me turn off the video. Somehow.